Welcome to Balaji Chemistry classes. Okay, please subscribe my channel, like the videos and give your valuable suggestions. Now in this video, we are going to come across about a concept called hybridization. In chemical bonding, this hybridization concept was very useful to find shapes of the molecules and bond angles. Okay, now before going to come across about hybridization, we must have certain idea of valency bond theory. And what are the drawbacks of the valency bond theory, we must know that. So by knowing the valency bond theory drawbacks, how to overcome these drawbacks of valency bond theory, how the process of hybridization was introduced, we will come across in this session. Okay, now see the board. Here I am not going to write detail about valency bond theory. Briefly we will discuss what is the drawback of this valency bond theory. According to this theory, atomic orbitals will undergo overlapping to form covalent bond. Let me explain formation of water molecule according to this valency bond theory. Okay, so oxygen atomic number is what? 8. Its electronic configuration 1s2, 2s2 and 2p4. Okay, now in 2s there are 2 electrons. In 2p there are 4 electrons. Okay, 1, 2, 3 and 4. Let me take here, this is the 2px orbital and this is 2py orbital and this is 2pz orbital. Okay, so in 2py orbital one unpaired electron is there, in 2pz orbital one unpaired electron is there. Okay, these 2p orbitals of this oxygen, they will overlap with a hydrogen s orbital. Hydrogen atomic number is what? 1. Okay now, and here electronic configuration is what? 1s1. Hydrogen electronic configuration is what? 1s1. Means in s orbital there is 1 electron with a hydrogen. Now this hydrogen, 2 hydrogens are there in water molecule. The 2 hydrogen s orbitals they are overlapping with what? Py and pz orbitals of what? Oxygen. Now let me write here, already you know that 2py orbital and 2pz orbitals are perpendicular to each other. Let us take this is the y-axis and this is the z-axis, suppose. Okay, if you consider z-axis is the internuclear axis. Okay now here this z orbital is pz orbital is having one unpaired electron. Py orbital is also having one unpaired electron. They are overlapping with hydrogen s orbitals. Like this, 2 bonds are formed in water molecule. So one is formed by s orbital of hydrogen with pz orbital of oxygen. The other bond is formed by s orbital of another hydrogen and py orbital of oxygen. Let us take this is oxygen. Okay, now this oxygen hydrogen bond was formed because of s orbital and pz orbital overlapping, and this bond is formed because of overlapping of s orbital of second hydrogen with py orbital of what? Oxygen. Now here whenever pz and py orbitals are perpendicular to each other, this bond formed is also perpendicular. These 2 bonds are formed are also perpendicular to each other. So then what will be the bond angle? 90. In water molecule bond angle according to valency bond theory, how much will get? 90. Not only this water molecule, let us take ammonia molecule also. So in ammonia molecule 3 bonds are formed. All the 3 will be perpendicular to each other because they are formed by px, py, pz orbitals. Like this, according to valency bond theory, any molecule you can consider bond angle will be 90. Okay, but how can that all the molecules will have that bond angle 90? There is a major drawback of what? Valency bond theory. If question is asking, according to valency bond theory, bond angle in any molecule if you take that will be 90 only. Okay, now this is one of the drawback of what? Valency bond theory. Next, see the word everyone here. So here let me explain methane molecule formation according to this valency bond theory. How methane molecule is formed according to this valency bond theory we will come across. Okay, now here I am explaining methane molecule formation. Methane is what? CH4. Okay, carbon is forming bonds with 4 hydrogens. So in methane molecule there are 4 bonds. How they formed according to this valency bond theory we will come across. According to VBT, how this methane molecule is formed we will discuss. Now carbon atomic number is what? 6. Electronic configuration is 1s2, 2s2 and it is 2p2. Okay, this is called ground state electronic configuration. What is this called? Ground state electronic configuration. In this ground state electronic configuration of carbon, there are only 2 unpaired electrons. Okay, but in methane molecule there are how many bonds total? 4 bonds are there. Means this molecule is not formed in ground state. Okay, let me write excitation electronic configuration. I can write it is 1s2, 2s1 2p3. This is called first excited state electronic configuration of carbon. In this state, what happens? S orbital is having 1 electron and 3 p orbitals are having so each orbital is having 1 unpaired electron. Total how many unpaired electrons are there? 4. Now this molecule, right? Now this carbon can form 4 bonds. Now this methane molecule is formed in what? First excited state. Methane molecule was formed in what? First excited state. Now according to valency bond theory, okay, so here carbon is having 1 unpaired electron in s orbital. Okay, remaining unpaired electrons are present in 3 p orbitals. Okay, let us take this is px and py, this is the pz orbital. Now here s orbital of carbon is overlapping with here 4 hydrogens are there total. Okay, s orbital of carbon is overlapping with s orbital of hydrogen. Okay, one is ss overlapping, one bond is formed by ss overlapping. Remaining 3 bonds are formed by what? Sp overlapping. Remaining 3 bonds are formed by what? Sp overlapping. So according to valency bond theory, in methane molecule, 1 bond is formed by ss overlapping and 3 bonds are formed by sp overlapping. Is it clear to you? So means all the bonds are not equal. But experimentally, when you take methane molecule, all the bonds are equal. Means according to this valency bond theory, we are unable to explain bond angles and equality of the bonds. To overcome this drawback, now next theory, that is a hybridization concept was introduced. So same methane molecule formation we will come across according to hybridization theory. So give me a minute. Now see the board here. So hybridization says that this direct orbitals overlapping is not possible. How that overlapping takes place? See the board here. First, in central atom, in methane molecule, central atom is what? Carbon. That carbon, in first excited state, so 1 unpaired electron is present in s orbital, 3 unpaired electrons are present in p orbitals. All they are intermixing. What they are intermixing. So 1 s orbital of carbon and 3 p orbitals of carbon, they are intermixing and they are forming new orbitals. Okay, this process of intermixing is called what? Hybridization. Now see the board here. I gave the definition for hybridization. The process of intermixing of atomic orbitals of almost same energy and their redistribution into an equal number of identical orbitals known as what? Hybridization. So the process of intermixing of atomic orbitals of nearly same energy. You can see here 1 s orbital, 2 s orbital, remaining 3 are what? 2 p orbitals. All they are present in second shell. Nearly they will have same energies and all they are intermixing. So to form new orbitals. So how many orbitals are intermixing? Same number of new orbitals will get. Okay, and the new orbitals, whatever they formed, they will have equal energies and identical shapes. Is it clear to you? So that process is called what? Hybridization, and the newly formed orbitals are called what? Hybrid orbitals. Newly formed orbitals are called what? Hybrid orbitals, and these hybrid orbitals will be oriented into different directions to avoid repulsions between them. Okay, now let us take here 1 s orbital is there, 3 p orbitals are there, they are intermixing to form total 4 orbitals. That orbitals are called Sp3 Hybrid Orbitals. These 4 orbitals are formed here. These 4 orbitals are called what? Sp3 Hybrid Orbitals. These 4 Sp3 Hybrid Orbitals are orienting into different orientations to avoid repulsions between them. All the 4 orbitals are occupying the corners of tetrahedron. Corners of what? Tetrahedron. That's what Sp3 hybridization is also called what? Tetrahedron hybridization. Now all the 4 orbitals are having unpaired electrons. Now after undergoing hybridization, whatever the new orbitals are formed, they are called what? Sp3 hybrid orbitals. These are overlapping with hydrogen s orbitals. Now let us take, so here this is hydrogen s orbital. So hydrogen s orbital, here hydrogen s orbital, hydrogen s orbital. Like that, there is a bond formation in methane molecule. Means all these 4 sigma bonds are formed by what type of overlapping? Sp3 hybridized orbitals of carbon with s orbitals of hydrogen. Like this, 4 bonds are formed by, all the 4 are formed by same overlapping, that is Sp3 s overlapping. And here, whenever the hybridized orbitals are moving into different orientations, so each hybridization will have unique shape and unique bond angle. So in Sp3 hybridization, the shape of the molecule will be tetrahedral, and bond angle we can say 109 degrees 28 minutes. Bond angle is how much? 109 degrees 28 minutes. And shape of the molecule is what? Tetrahedral, when the central atom is undergoing sp3 hybridization. Like this, sp3 hybridization concept will give the idea of shapes of the molecules and bond angles. Each hybridization is having unique shape and unique bond angle. Okay, hybridized orbitals are moving into different orientations to avoid repulsions between them. That's what each hybridization is having unique shape and unique bond angles. Okay, now. Right, here you can remember one more point. Hybridized orbitals always forms sigma bonds. Unhybridized orbitals means what? The orbitals which are not participating in hybridization, they will form what? Pi bond. Already in valence bond theory you come across end-on end overlapping will form sigma bond. Lateral or sidewise overlapping will form pi bond. Now, so how that drawback of valence bond theory will overcome is clear to you because of this hybridization concept. So methane molecule is formed here. It is in tetrahedral shape because carbon undergoes sp3 hybridization. All the 4 bonds are formed by same type of overlapping, that is sp3s overlapping. Is it clear to you? Now here in excited state that hybridization is taking place, but in every molecule there is no condition that excitation, after excitation only that hybridization can take place. In ground state also hybridization can take place, or in excited state also hybridization can take place. Okay, so excitation is not essential criteria, okay, to undergo the hybridization process. Now here always the orbital should not contain unpaired electrons only. Empty orbitals can participate in hybridization, unpaired electrons containing orbitals can participate in hybridization, and here paired electrons containing orbitals also can participate in hybridization. Okay, now how many types of hybridizations are there? Based on the different hybridizations, how can we explain the shape of the molecule we will come across. Okay, now this methane molecule formation according to hybridization concept is clear to you. Okay, let me come across about different hybridizations. Okay, right. Let us come here. We'll discuss that based on the number of sigma bonds, how can we find the hybridization? See the board. If a central atom is forming 2 sigma bonds, the hybridization is what? Sp. Okay, I said you already, hybridized orbitals always forms sigma bonds. Now come here, when 2 sigma bonds are there, hybridization will be what? Sp, and the shape of the molecule is what? Linear. That's what Sp hybridization is also called linear hybridization. Now let us take the example of BeCl2. In that beryllium is forming 2 bonds with 2 chlorines. So the bond angle will be how much? 180. Bond angle is how much? 180. Okay. Next, let us take 3 sigma bonds are formed by central atom. Then the atom will undergo what? Sp2 hybridization. 3 sigma bonds means what? 3 orbitals should participate in the hybridization. 1 s orbital, 2 p orbital. Then the shape of the molecule is what? Trigonal planar shape. You can take the example of what? BCl3. Okay, boron trichloride molecule you can take. In this boron will undergo sp2 hybridization, and that orbitals are overlapping with what? Chlorine p orbitals. Like the trigonal planar shape will be there for BCl3 molecule, and here bond angle will be how much? 120. So sp2 hybridization is also called trigonal planar hybridization, and bond angle is what? 120. Now come to here. If a central atom is forming 4 sigma bonds, then it will undergo sp3 hybridization. Okay, the shape is what? Tetrahedral. Already this example we come across. Now here I am giving the example is what? CCl4, carbon tetrachloride. Now see the board here. So around carbon 4 bonds are there. They are occupying the corners of what? Tetrahedral. Okay, the bond angle will be how much? 110 degrees, 28 minutes. Now next, if you consider that if a central atom is forming 5 sigma bonds, okay, 5 orbitals should participate in the hybridization. 1 s orbital, 3 p orbitals, and 1 d orbital. After completion of 3 p orbital, so there will be d orbital in the valence shell. That's what? 1 s orbital, 3 p orbitals, and 1 d orbital. Total 5 orbitals will involve in the hybridization. Okay, now the shape of the molecule is what? Trigonal bipyramidal shape. When a central atom is undergoing sp3 hybridization, then 5 orbitals will be distributed in this way. Okay, so 3 are occupying the corners of the triangle. One is above the plane, other one is below the plane. Let me draw the structure here. PCl5 structure I am drawing again. So let us take this. The central atom is phosphorus. 3 bonds will be present in the triangle. So 3 chlorines will be occupying the corners of the triangle. Okay, so it makes triangle. And here bond angle will be how much? Bond angle will be how much? 120. Okay, this bond angle will be 120. And one is there. One chlorine is there above the plane. Okay, and another chlorine is there below the plane. Here let me write chlorine. Here also our chlorine is there. The bonds which are present in the same plane are called equatorial bonds. What are the bonds called? Equatorial bonds. This equatorial bonds they are called. The three equatorial bonds are there here, and the bond which is present above and below the plane is called axial bond. What is the bond called? Axial bond. Now this axial bond will have more bond length and equatorial bond will have less bond length in trigonal bipyramidal shape. In trigonal bipyramidal shape. Okay. So here whichever the bonds present is above and below the plane are called axial bonds. The axial bonds are having more bond length and these equatorial bonds are having less bond length. Okay. So within the triangle the bond angle is how much? 120, and the chlorines which are present above and below the plane axial bonds, which makes with plane how much angle? 90 degrees. That's what here two types of bond angles will be there. Okay, one is what? 90, the other one is what? 120. So the bonds which are present above and below the plane, which makes with plane 90 degrees, and the chlorines which are present within the plane, same plane, so they are having bond angle 120. So the bonds which are present within the plane are called equatorial bonds, which are present above and below the planes are called what? Axial bonds. They may ask a question like this, okay, among the following, in which molecule different bond lengths, different bond angles are there? Then you can go for a Sp3 hybridization. If in any molecule central atom is having 5 sigma bonds, it undergoes Sp3 hybridization and it will be trigonal bipyramidal in shape. So there are different bond lengths and different bond angles. Okay, now next come to the example. If central atom is forming 6 sigma bonds, then the hybridization is what? Sp3d2, 6 orbitals are involved here, 1 s orbital, 3 p orbitals and 2 d orbitals, and the shape is what? Octahedral shape. Okay, here I gave the octahedral shape. You can take the example of SF6. Okay, so here sulfur is the central atom, 4 fluorines are occupying the corners of the square, and one is above the plane, the other one is below the plane. So within the square, bond angle is 90, above the plane and below the plane, which makes with plane 90 degrees. Here all bonds are equal and the bond angles are also equal. Don't compare with this PCl5 structure. Above below plane is there, they are axial, and here also don't consider they are axial, because here all the bonds are having equal distance and bond angle is only one, that is 90. Okay, now so all these 6 orbitals, okay, in Sp3d2 hybridization, how many orbitals are involved? 6 orbitals. All the 6 orbitals will be occupying the corners of octahedral. In octahedral, all the faces will be equal. So you remember that one? So unlike that PCl5 structure, in SF6 there is octahedral shape, all the bonds are equal, bond angle is also one only, that is 90. Okay, two types of bond lengths, two types of bond angles are not present in this octahedral shape. Now you can come to the last example. If 7 sigma bonds are there, 7 orbitals should participate in the hybridization, 1 s orbital, 3 p orbitals, 3 d orbital, total 7. Okay, that's hybridization is called Sp3d3 hybridization, and example is what? IF7, and the shape is what? Pentagonal bipyramidal. 5 bonds are occupying the corners of the pentagon, one is there above the plane, other one is there below the plane. Okay, now bond angles are 72 and 90. Like this, each hybridization is having unique shape and unique bond angle. Based on the number of sigma bonds, we can know that hybridization of the central atom, and we can find the shape of the molecule, and we can know the bond angle. Like this, we can come across about hybridization concept. Is it clear to you? So you can find the shapes of the molecules and bond angles in this way. Okay, so take the screenshot of the board. Okay, like the videos and subscribe my channel. Thank you. You can take the screenshot of the board.